Thanks for everybody for coming today. My name's Newman. I'm the technology founder and CEO of a company, CloudCheckr. We build tools to actually help you address what we're going to talk about today. I tell you go down to the exhibit hall, but that's closed. But what we're going to talk about today is thinking about how we want to secure these workloads, how we're actually going to rethink how we do security. A lot of what we do with security today needs to be rethought as we move our workloads into the cloud. The cloud is not just a matter of where you're going to put your servers, right? It's more of how am I going to re-architect, how am I going to redeploy, how am I actually going to build my application? So when you start to think about and take the real advantage of the cloud, is this re-architecting and thinking about things as ephemeral, elastic, auto-scaling. You really need to rethink how you're gonna secure that. If you go to a typical security show today, a lot of it is how do I put a better threat agent on a machine, right? How do I put a better malware agent, right? That idea goes away a lot in the cloud. The cloud is much more about thinking a little differently about how am I going to protect my workloads, and how you're going to actually do that in a way that is effective and efficient. So I'm going to focus today more on not focusing on the lift and shift and more on if I pick up my workloads, re-architect them, put them in the cloud, what's the right way to secure them? How am I actually going to be effectively securing them when I do things the cloud agnostic way? What I really hope you walk away from this today is some motivation to start thinking about that, right? Is to go home and start saying, I'm not going to go find a better malware agent to put on my servers and call that my security. The fact that you're here is a good sign that the people in this room are thought leaders around security. They're thinking about what's the next generation, what's going to happen as we move stuff into the cloud. And the fact is, 99% of the workloads in the future are all going to be done on these ideas, these utility cloud computing platforms. So you have to start thinking about how am I going to do security first that way rather than, how am I going to take what worked in the cloud or in the data center and apply it to the cloud. So reevaluate what you're doing. Think about what's the perspective. Things like intrusion detection just aren't going to work the same way. You don't own the network. You can't just plug into a span port and monitor what's happening there. So you need to rethink how these are going to happen. Things like your vulnerability assessment programs have to entirely be rethought. How am I going to do pen tests? All of these are just vastly different, and we're going to start covering each of these as we go through. And you really need to really understand, what are the how do I get a better understanding of the AWS services? How am I going to do perimeter assessments? How am I going to do internal and external threats? And how am I going to monitor these in the cloud? Very different. So change that perspective. And the easiest way to think about it is what is your perimeter in the cloud, right? How do we do a perimeter assessment in your data center or your on-prem, right? You know what your IP addresses are. You go buy a tool. You start scanning it. You see what kind of holes are open, and you scan it by basically taking a tool like a Nessus, running against an IP block, throwing packets at it, and see how it responds, right? Entirely not something you can do in the cloud, and you can't do it for a half a dozen reasons. The first one is it's against your terms of service. You can't go running those type of scans in an AWS cloud because you're on shared infrastructure. The other reason is just not going to work because you don't have IPs that are contiguous. You don't have a network block. You have these workloads that are being spun up. Their IP addresses are changing. You don't have defined IP addresses. You may have some defined IP addresses, but the idea is you have this workload that's polymorphic, that's changing, that's ephemeral. And so what we used to do for perimeter assessment entirely isn't going to work. But the fact is, you can actually do a much better job in the cloud because the fact is you don't want to use tools like Nessus to do that. You want to use the APIs to actually go out there and pull the list of your resources, pull your configuration, pull all of that. So focus on how am I going to do this differently? Rethink how you're going to do everything from perimeter security, encryption, all of that. So again, in your data center, your perimeter security was setting up a firewall, setting up access points, and then configuring your IDS, your IPS, all of that. And then you'd go gather those, do port scans, all of that, sniff lots of packets. You can't sniff packets very effectively in the cloud, right? So a lot of the firewall vendors are kind of sitting there saying, well, what am I going to do with my business? Because in the old world, I could put firewalls out there, but and all the traffic would go through it. Cloud's very different, right? All the packets are not going to flow through a single point, through a single firewall. So you're going to have tons of firewalls out there, or tons of different points, and it's very hard to go and monitor or set your perimeters, or set your perimeter there, set your firewalls there. So it's just not going to work. And the idea is this. Microsegmentation, right? Another thing that's really powerful in the cloud is the idea of microsegmentation, right? Setting up really small networks, and in your data center, again, to set up a segmented network, segmented LAN was very expensive, right? You have to go buy a router that costs a couple $100 or $1,000. You have to get some physical cables. You have to do a whole bunch of stuff that's very complex, expensive. In the cloud, in AWS, it's basically, first of all, it's free, right? There's exactly zero cost associated with setting up another microsegment, and it's very easy to do. I can write a script to set up a microsegmentation network in seconds, tear it down hundreds of times a day. So it's just much easier to set those up, which means you can do it much more effectively, efficiently, and you're going to have a lot more segmented networks. But the outcome of that, though, is what are you going to do? Put a firewall on the hundreds or thousands or tens of thousands of microsegmented networks? It's just not practical. So we have to rethink how we're going to do all this. How are we going to design this so that we can still have security on each of these little networks, but I just can't afford to put firewalls, an expensive firewall on every single one of them. And think about it from your organization's perspective. You have these hundreds or thousands or tens of thousands of microsegmented networks. They're not all sitting together. They're just sitting out on the out in Amazon somewhere. So keeping track of who's got what microsegmented networks out there, are they properly secured? This becomes your challenge. So so you want to rethink how you're doing this. I'm going to jump to this slide and then come back and talk about, you have this shared responsibility model for security now with AWS, right? So you don't have to worry about data center security. You don't have to worry about the part of your compliance requirements for FedRAMP and FISMA and all that applying to the physical side of it. But you still do have a lot of responsibility around what you're going to do in the cloud. How am I going to set up access controls around each of the services? How am I going to open them up? What kind of policies and procedures around that? So you still have a big piece of it, but this whole top part has been taken away from you. You don't have to worry about it anymore. So, but what it's done is it's changed to the idea of, before, if you wanted a hard drive, somebody would go buy a hard drive, somebody would walk into the data center, plug it into a machine, right? So instead of doing that, you virtualize that. It's an API call that does that today. So through that API call, you've created this, this physical world that's through the API. So you need to guard that API very carefully, right? That API is your physical world in the cloud. So make sure you're protecting those through everything from multi-factor authentication, really strong IAM best practices. That's your new physical security. So that becomes very, very important to control IAM access as tightly as possible. So the principles aren't going to change, right? You want to reduce your surface area. The idea that you have microsegmentation is so much easier to do, and you can do so much more and segment it in so much more ways that it's going to help you reduce your surface area, right? But the other challenge of the microsegmentation and the cloud is that before you knew these were my 5 servers, in the cloud, you're going to have these 3 servers today. You're going to have 10 servers tomorrow. You're going to have 7 servers the next day. They're all going to have different IPs. They're going to have different servers, instances. So it's a little different in how you're going to handle that dynamic, ephemeral environment. So your surface, you still have to reduce your surface area. So when you're going to set up your NACLs and your security groups, it's absolutely important that you take least privilege. You make sure that you're not opening up anything that doesn't need to be opened up. Defense in depth, you still got to practice that. You got to assume somebody's going to get past your outer defense, and that might be simply because you have internal threats, right? So you still need to follow these. Other attack vectors aren't going to change. For instance, application level attacks, things like SQL injection, cross-site scripting. These still are going to be the same. You're going to have a web server, and you're going to have to worry about user privilege escalation, all of those. Operating system vulnerabilities. When you have that operating system, you're still going to have to worry about patching it. You're still going to have database vulnerabilities, all of that. Some things are a little different, right? Again, you're not going to be able to sniff packets the way you did in your data center. So by not sniffing packets, you're not going to have as much visibility into what's happening. So you need to understand that and use some of the tools that AWS provides you to get you some visibility there. But you're going to lose some visibility of what's happening. The other interesting thing is this idea of these kind of polymorphic targets or mapping, where an attacker used to, if they knew this was your server, they could spend weeks or months or even years attacking it, and give it enough time, it really increases their likelihood of being able to penetrate into a server. So the idea is your workload is changing so often that if they may stumble upon one of your servers, it's gone in an hour or a day, then that really reduces the exposure that server hit. So really, this idea of polymorphic workloads, ephemeral workloads, actually really helps your security. It really helps make it much more secure, and even advanced persistent threats is a big piece of this, right? I mean, if you look at targets of the world and all those kind of all those kind of attacks that were particularly dangerous or damaging, they were all the product of what you call advanced persistent threats, APTs, and they were somebody got in and they sat there for weeks until they found another hole that they could escalate their privileges, and they did that, right? When you have these polymorphic or dynamic workloads that are getting spun down and respun up, then if somebody does get kind of a foothold into your network, foothold into your workload, that server goes away, that advanced persistent threat also goes away. So very effective once you start thinking about this against advanced persistent threats and these type of attacks. It really makes the hacker's job much harder to try to break in. So as we talked about the idea of perimeter assessment in the cloud, how am I going to do this, right? So, you need to use the API to do things like I'm going to go get a list of what are all my VPCs out there, what subnets are within them, what do the routing tables look like, what do my network access control lists look like, what do my security groups look like? And then the big challenge at the end is I have all these resources within that are changing on an hourly, if not minutely basis. How do I actually understand those, map them? And so you need to think about it. It's not going to be I need to list the IPs that are within that VPC. It's more of I'm going to have to understand the auto-scaling groups. I'm going to have to understand the AMIs that those EC2 instances are built off of. So you need to rethink how you're actually going to inventory yourself. So the idea of change management, right? All of us have CMDBs, change management databases. Today, they are a list of IPs and a list of hardware, right? Well, we're going to have to rethink how that becomes more of a metadata about what the workload looks like, how it's configured, whether the workload is patched, not servers. And I'm going to get into this later, but you want to be patching basically workloads, not servers anymore. And what does that mean? We'll go into that, but that's how you have to think. So let's dig a little bit into the virtual private cloud. That is a big, big piece of the AWS security puzzle, right? So a virtual private cloud is basically a logical way of segmenting your network, of cutting it off from the rest and separating it out. So it's composed of, these gateways that let it get in and out, right? So the gateway, if a VPC doesn't have an internet gateway, or it doesn't have a direct connect, or it doesn't have a VPN gateway, then nothing can really get in and out, right? So that's fairly secure. So you need to understand all these different types of gateways. You need to understand the subnets that sit within the gateway, because the subnets are, nothing can actually be put in a VPC. It has to be put in a subnet that sits in a VPC. The routing table dictates how the traffic comes in and out. So that's really your first layer of defense, is if you don't want traffic getting routed out of this network, then make sure the routing table is restricting that. You're going to have network access control lists. These are firewalls. These are virtual firewalls, and they don't have the complexity that an F5 or a Cisco or whatever the other popular firewalls have. But they give you some pretty complex rules to begin with. Security groups, which are basically host-based firewalls, and then you have the resources that sit within that. So, and if you look here, this is kind of a map that shows you all the capabilities. If you understand this, it gives you a really good perspective on how packets are flowing back and forth and what's the right places and things that I need to do to control myself, to secure myself, right? So, and take some time, even if you're not particularly technical, I would suggest take a look at this and really understand all the pieces, what's happening, because if you understand this, it gives you a really big heads up on how things happen within an AWS VPC. So the network, so how do you do network security in this VPC, right? That's the first piece. Your network access control list, right? That is the outside. I like to consider that the outside layer. It's stateless. And what does that mean? It means that when a packet comes in, it also has to go out, right? And when it comes in on one port. When it goes out on a different port, right? So if you're stateful, then you remember the packet coming in and you can allow the packet going out that matches, right? NACLs don't work like that, right? They don't remember things as it comes. They don't remember the other side of the connection. So you have to understand that. So it really makes it complex, because when you let a packet in on, let's say, port 1533 or 1433, which is a SQL Server port, when it goes back out, it goes over a different port, some high port above 523, or depending on your operating system. So if you want to block things, or if you want to allow things, right? If you want to allow SQL Server into that VPC, then really you can allow it in, but on the outside, on the outgoing way, you have to allow everything over port 523 or whatever your operating system is. It's a high number, but you basically have to open up wide stretches of ports to allow in and out, which becomes problematic because it basically allows more than it should out. So these stateless, the idea of NACLs being stateless, it's very good for one thing. It's very good for denies. Right? So I have a network, I have a VPC, and I know I shouldn't be allowing SQL Server, Telnet, FTP, a bunch of other really not very secure protocols. I can shut them off, right? So it makes it very easy to shut things off, right? By default, in most VPCs, the NACL is just wide open. Most people don't use NACLs. Very rarely do I see people using NACLs to secure the traffic, but it's very effective for blocking the bad things. So security groups is where the majority of the secure configuration happens that I see. And this is stateful, meaning if I open up port 1433 inward, it will allow the other side of that connection to happen without understanding what the port is. So use those, but make sure that you're using them. You shouldn't be creating security groups that are just wide open. Right? That is one of the policy best practice 101s is don't allow anyone in your organization to create all IP addresses and all ports. Just is not a good idea. So you got to understand too. What are the IP addresses and how do they look like and how are they handled within Amazon? And specifically EC2. EC2 instances can be run inside of VPCs. They also used to be able to run outside of VPCs. That, unless you have an old account, you can't do that anymore. But an EC2 instance can have one or more public IP address, right? So by default, it's going to get a public IP address that's just a random 52 dot something. And so you have to understand that even though you didn't assign what they call elastic IP, most people use an elastic IP to actually get to an EC2 instance. But even if you don't assign elastic IP address to it, it will have an IP address. Now, so can a hacker go find that IP address? Not really. What they can do is just stumble across it, right? I am sure that there are script kiddies and hackers who are just randomly poking anything with a 52 dot something out there. Right? And they are looking because they know that that's the EC2 address space, it's well defined. So even though nobody knows what your address is, even you you spin it up, it's different every time. People are poking at it, so understand that and be careful of that. You're also going to get a private IP address, which can only be routed to locally, so it has to be within your subnet or within your VPC for somebody to get to it. So you're going to have at least those 2 IP addresses assigned to an EC2 instance, and you're going to have, and then if you need to actually have something that's static, you would assign an elastic IP address to it. So understand all that to make sure you haven't accidentally exposed something. Very easy to put it out there and say, oh, I didn't give it an elastic IP address. How would anybody ever get to it? It has a public IP address by default. So what am I going to do with vulnerability assessment in my cloud environment, right? In the old world, or if you lift and shift, I got 5 servers there. What's my vulnerability assessment program? It's every quarter I go and run Nessus against each of those servers. I take the report, I review it, and I fix anything that's red, right? I mean, that's what we all do. That's not going to work in the cloud, right? Because the workload is going to get spun up, it's going to get spun down, there are different IP addresses, different servers. So you need to think about more of securing the AMI, right? So rather than go and scan all 5 of those, and tomorrow it's a new 5 or a new 10 servers and try to rescan those, what I want to do is take that AMI, spin it up in a test environment, go run my Nessus against that, go fix everything there, whatever it is, applying patches, reconfiguring stuff, create a new AMI and make sure my workload is based on what I consider my latest secure AMI. Right? So that's how you're going to have to rethink, is rather than actually scanning live production servers, you're going to be scanning test beds from the AMI, make sure that's kind of marked as gold or up to date, and then use that. The other piece of that, though, is once you do that, how long before you should scan it again, right? I mean, if this is an AMI that's running a workload that no human being touches, then you can consider the drift from that AMI fairly minimal, so it can be fairly secure for a longer period of time. But if this is an AMI that some human can log into and starts browsing and can browse some kind of end up with some malware on top of it, then you want to really shorten that period between how long you redeploy it or how long you're gonna scan that server. So if that server, even if the AMI was secure 60 days ago, if that server's been running for 60 days, it kind of falls outside of the fact you scanned it 60 days. You may have to rethink. So you could see the complexities of how am I using this AMI, how am I using my servers, and that's going to affect how I'm going to do a VA program. And the other side of it is what's my patching strategy in the cloud, right? Ultimately, your patching strategy, or ideally, your patching strategy is what Gartner calls the no patching strategy, right? And that doesn't mean you don't patch. What that means is you're never patching a live system. And this is where the cloud is really, really cool, is the idea that you're not patching live systems. Your servers, when I may have a workload with 500 servers, right? In the old world, what would I have to do? I'd have an army of people running out trying to apply 500 patches and do it as quickly as possible, and that would take about 6 months, right? And then we'd end up with things like WannaCry, right? Instead, if we adopt these cloud principles of I can instantly redeploy the entire workload with the click of a button, with running an automated script, right? If we can get to that world, then the idea of patching becomes actually fixed, right? Because what I'm going to do is patch the one server that's kind of my gold AMI image, and then I'm going to kill all my servers out there, or I'm going to kill them in phases, and I'm going to start redeploying them, right? If we can do that, then patching doesn't become this onerous process every second Tuesday of the month when Microsoft does a patch release, or it doesn't become this freak out when a zero-day exploit happens. It really becomes a fact of your DevOps says, there's a new issue, I need to patch it, and now I need to redeploy the workload, right? That's where we actually fix this problem of patching, is when we can get to that state. But you want to have that no patching strategy. Don't patch your live systems. Think about redeploying everything. Of course, at that point, it becomes uber important to make sure that your gold image AMI is perfect, right? Make sure that that's a trusted repository, a high assurance repository. So you have to be really, really careful with that. But this is how we fix the patching problem, as well as really battle that advanced persistent threat issue. So what are we missing, right? So again, everything I covered so far was all about how do I secure EC2, right? And what's the hacker going to do? Is he going to go after the strong place that you put all these advanced tools and really lock down, he's going to look for your weak link. He's going to look where you didn't actually lock down. And I'll talk for a couple things, right? What are the things that have recently hit around the AWS world on the security side, right? So there was a couple weeks ago, there was a thing about, somebody in DoD had inadvertently left some files on what they called a server with no password, right? And so if you actually read it, what it was somebody put, one of the SIs, highly regarded SIs, put a bucket, S3 bucket with public permissions, and just left a bunch of files out there, and they didn't even realize there were sensitive classified files in it, right? And so this is not hacking. This is just, misconfiguration. It's back to the old days where people would just, inadvertently put the wrong files into a public network drive that just had no permissions on it. It was the same situation. But even if all your permissions were set properly in EC2, how does that protect against S3 not being properly locked down? Because S3 is not within a VPC. So, and a lot of times you say, well, my S3 bucket name is so esoteric and it's not in Google and it's not linked from anywhere. How would anyone find that? So, I don't have to worry about it. That's what you consider security by obscurity, right? Hoping that somebody doesn't know the name of it, hoping that somebody doesn't reveal it. And really how this was detected was, not by a malicious actor, but by a security organization, security researchers. I think it was UpGuard is the name of them. And they were just scanning for public S3 buckets, right? So they're scanning for public S3 buckets and came across this. I could tell you there's probably a lot of bad actors out there right now who are scanning for public S3 buckets. And the other side of that is I know for a fact there's a lot of people that have sensitive information on S3 buckets that are public, and they've just inadvertently forgotten they put it out there. So you need to be aware of that. So what are other things, right? So S3 buckets, not within a VPC. I myself got an email from Amazon the other day. So Elasticsearch domains, you can have public domains on your Elasticsearch. They sent out an email telling everybody you need to not have public domains in Elasticsearch because there's active attacks going on against it. Right, so be aware of that. So again, Elasticsearch, not within a VPC, right? Chaos Club in Germany, 3 or 4 weeks ago now, I think it was 2 or 3 months ago now, they had a presentation on hacking Lambda, and they actually did things like how do I run a shell from within a Lambda function, things like that. So you could see, again, the attackers are not going to go after EC2. If we're doing a good job with EC2, we're doing a good job with VPC, they're going to find the other areas that they can go after, they can attack. So you need to be aware of not just the standard VPC services, but the other things that exist that are being used within your organization or could be used as the weak link in the chain. So don't assume all the attacks are going to happen against EC2. There's over 80 different AWS services, probably more than that. I don't know what they released today, but it's always a challenge to keep up with those. The IAM authentication, you want to centralize that. That's another issue, right, is when you have, great, all your AWS accounts are decentralized now, right? So you have hundreds of different people in your each department owns their own account, can move quickly, can deliver applications cheaper, more effectively. But what happens is each of those have their own security levels. That some of them will care more about security, some of them will care less about them. So when you have these hundreds of accounts, you have to start worrying about who out there is not as diligent as they should be. So you need to stay on top of that, right? That's going to become your weak link in the chain, is somebody out there who wasn't as diligent as they should have been, and they become a backdoor into a different account or a backdoor into somewhere else. So keep track of all those Amazon accounts, figure out how you're going to understand all those. IAM, you're going to set up IAM, and if you allow everybody to kind of use their own IAM within each account, then when somebody leaves the organization, how do you effectively know to go turn off their IAM access within all the accounts that they were in? So I'm a big advocate of using federated security day one with Amazon, right? And don't wait till you get to 50 accounts because now it's too hard. But use that federated security day one when you're using AWS, and whether that's integrating with a ping one or whatever your own security is, do that. So the RDB Relational database service, RDS, right? So there's a whole different set of services. They can exist within a VPC. So make sure they're in the VPC, secured properly. Databases are not ideally designed to withstand the attack on the internet. So you never, I tell you, it's very, very rare that you should open publicly accessible on your RDS databases. There's too many vulnerabilities around them. If you do have to open it up because somebody needs to connect to it, make sure you're restricting it very, very tightly to small groups of source IP addresses. Make sure you're on the latest version of the database. Whether that's whatever database you are, try to keep up to date, and it's super easy in RDS to do that. So make sure you're up to date with that. Make sure you're securing the snapshots, keys to the kingdom. So if somebody else can get a copy of the snapshot, that's just as bad as getting a copy of the entire database. So, and there's lots of cool things. Encrypt your snapshots with KMS keys, right? So you have all the capabilities and the features within AWS to be really, really robust about this, so use them. S3, as we talked about, you can set your S3 buckets to be restricted only to a VPC, so you can use VPC endpoints. So go do this, right? That gets you a lot of security by doing that. I know VPC endpoints was just extended to DynamoDB, so the same thing. I strongly recommend you set your DynamoDB to only be accessible through VPC endpoints. But make sure, don't ever grant full control to this group called everyone, because first of all, it exposes what's in there, but more importantly is even people can start putting files in there. So they can, start putting malicious files in there, see if somebody within your organization, they might put a Word document with a macro virus in it, right? And you go and say, what's this file? You open it up, now you're infected with that macro virus, right? So there are lots of issues with allowing people to put files, not just read them. The other piece is, there's the everyone, but there's also the all authenticated users. Right? So you can grant all authenticated users read access. It doesn't sound particularly dangerous, right? Because if somebody has an account in your system, then you might trust them. But all authenticated users actually means all authenticated users in the entire AWS domain, right? So it basically means everyone, because anyone can go create an account, and they're now, even though they're not associated with your account, they are an authenticated user. So understand that subtlety, and the fact is all authenticated users is basically everyone. So go never grant either of those two groups anything. Obviously if you're putting S3 files out there and you want it to be a website, you can put everyone as read access, right? But make sure that's really your intention. But full control seems like it's never a good idea. But S3 has every configuration, secure setting, it has everything you could imagine. There's nothing that S3 doesn't provide you. Server-side encryption, multiple forms of it, HTTPS support, access logs, IAM policies, bucket policies, really, really rich. But again, it's our responsibility to use it properly. And as we just kind of covered with that system integrator situation, all it takes is one slip to inadvertently use it the wrong way. So other services, Amazon SQS, same ideas. It has its own access control system. So it has its own. It's within a region, not within a VPC. So again, it's public, right? So you're going to see that IP address there. Anyone can get to it if they know your account name, your account number. So you have to understand that, and yeah, maybe people won't know your account number, but that's probably not your security posture. I hope nobody learns my account number. They have policy documents that are different than IAM policy documents. So even if your IAM is perfectly secured, you make sure you're reviewing your SQS policies as well. Same way SNS. SNS has their own policy documents. They don't live inside of a VPC, so make sure you've locked this down as well. So even if your NACLs are as restrictive as possible, you need to also review your SNS and your SQS policies to make sure that they're properly locked down. And there's lots of these services, right? These are the handful I've gone over, but DynamoDB you have to review. Anything that's not in a VPC, you should go review the security of that and make sure that you haven't inadvertently exposed anything. CloudTrail, right? So you also need to record who's doing what within your environment. And here's an example, another very common kind of issue that happens. Why do end up people getting hacked in an AWS environment? Because they do stupid things like access keys. I put it in source code, and then I think it's cool to push that to GitHub to share with the community, which is a very good thing, but you left the access keys in it. And believe me, it happens like on an hourly basis, right? And hackers have set up the systems where they're just out there looking for regular expressions that match that, grab it, and then most of them seem to, all the ones I've ever seen have not, most of them are not malicious in terms of, it's not somebody trying to steal some of your data, because it's much more lucrative. What they just do is Bitcoin mining, right? Is they grab these and then they go into your account, go to a region you're not using, and then they just spin up as many C4, 8, or whatever they're, C4, 8, or C3, 8x or largest, whatever the big ones are, and just see if they can get 7 or 8 hours of Bitcoin mining out, and they might net a couple $1,000s out of that, right? So that's typically what we see happen. But we've gotten to the point also where AWS is so good about this that they actually, within hours, if not minutes of you doing this, they'll actually try to shut that key down themselves, right? Because they'll see this happen, they know how to trace it back to your account, and will try to shut it down, probably because they've been burnt so many times with this too. And then they'll send you an email and say, don't do that, and like that. So, but CloudTrail is one of the services that records everything that happened. So after the fact, you want to know, how did this person get in? All of a sudden you see your bill exploded last night. You need to be able to get in and say, how do I know, what they did? How did they get in? Which access did they get in? What did they do after they get in? Did they just Bitcoin mine, or did they actually go into some of my backups and take a copy of that, right? So CloudTrail, you need to make sure CloudTrail is enabled. It's not enabled by default, so it really does make sense to turn it on. It's very inexpensive, so I mean, really the charge for it is mostly the S3 files, which is pennies or dollars a month. So go make sure you turn it on. Even if you think, this is a dev account, I just don't care. That's not a good reason not to turn it on. You really should be turning it on. Just best practice across every single account out there. And there's a new setting that you can use for multi-region cloud. Go set that one, right? Because otherwise, a couple years ago, before they added this multi-cloud region, you could set it in 5 regions and leave it off in 3 or 4 regions, and then the attacker, if they were in those regions, would they be masked? So, right, that doesn't do any good for you if they can find a region and do what they're going to do outside of there. So everything you do in AWS goes through that CloudTrail and goes through the AWS API, so it'll get recorded in CloudTrail. So use CloudWatch Logs, right? So another really nice feature that Amazon offers us is CloudWatch Logs, where, again, all your logging on your operating system, right? I have Windows NT logs, I have syslogs running, and they record things, logons, unauthorized access attempts, all of that. Now, what happens when I have a dynamic workload where the servers are torn down every couple hours? I lose those logs because the server's wiped out, right? That's a bad situation. So what Amazon provides you instead is the ability to forward the logs to CloudWatch Logs, which is just a central repository to store them all, right? So even though your servers are going away, you can maintain those logs in a central place that you can then do alerting on them. You have historical access to them, all of that. So make sure it's going to require you to install a lightweight agent from Amazon onto this box, point it at your server. You need to be careful about, this can run out of control if you run too much logs through there, but it is important to turn it on and use some of this. VPC Flow Logs, again, another very, very nice feature that you have to turn on, but this allows you to actually see who's connecting in and out, right? So you might not record every connection in because it can get overwhelming, particularly in a big, very active network, but at the very least, if you're not using VPC Flow Logs to monitor for unauthorized or rejected packets, then you're missing a lot of that visibility. So this is how you're going to get back a lot of visibility of who's connecting in, who's trying to connect in, And even, so it's interesting if you want to watch your VPC Flow Logs from an external view, right? From the external view, no matter who you are, you're going to see a bunch of unauthorized access attempts. It's just the background noise of the internet is that hackers and script kiddies and automated bots are just trying to poke every IP address that possibly exists, right? So if you turn on your VPC Flow Logs for the external world, you're going to have that background noise hitting. So, I don't know that there's a ton you could do about that. You probably ought to know that it's happening, but really what's critical is the internal, right? If I see from one subnet to another subnet and I start to see blocked access there, that probably should be really interesting and something that you really, somebody's misconfigured something and you ought to go fix it, but more importantly, is that some kind of lateral side attack, somebody trying to get from one subnet to another one, but you really, if you see something happening there, that should be bells and whistles going off. So go try to turn on your VPC Flow Logs, monitor for those deny connections, and use that. So again, I'm from CloudCheckr. You're going to have, a lot of people today are what they're doing is taking their tools from the data center, putting in there. Okay, I'm going to have a malware agent for the operating system, which you ought to have, but the question is that enough? Are you properly managing the control plane? And does that scale an environment where I'm using containers and things may not exist for more than a couple minutes or hours? How's that agent going to work? So be thinking about your security. How am I going to do it in the cloud? Look at people who have the security competency. The AWS security competency is important, right? Because that really shows that it's at least been tested to some minimum level of working in the cloud. And check us out, CloudCheckr, for monitoring, reporting, and optimization. So we give you visibility and best practices around all the stuff that I've talked about today, really enable you to leverage that across large environments, gives you the transparency to see what's happening in complex environments with lots of accounts, gives you automated capability to respond to some of these issues, to do fixes across large environments, and to give you the monitoring and the intelligence to know what should I be looking for, what are the 80 services that I don't know about, and what have I misconfigured something within there. So I have a couple minutes, so if you guys have questions. Yeah, no questions, but if you want to come up and ask, I'd love to chat with you after the fact. So again, thank you, and come check out CloudCheckr. Go to cloudcheckr.com, sign up for a trial. I'd love to have you. And thanks for coming, everyone.